So we are still in the business of making sure that the bases are the same, because if the bases are the same, then we can set the exponents equal to each other and solve them that way. So in part D, we could express 25 as 5 squared. But notice that it has an x, so I'm going to put the x right next to that 5 squared, because 5 squared is 25. Now because these bases are the same, I can set the exponents equal to each other and then solve. And that's our answer for D. By the way, you could of course check this answer, right? You can plug in a 1 in here and see how that affects the whole problem. And also put the 1 in here as well. E requires us to do two things. We'll have to factor tree to 32. And so 32 becomes 2 to the 5th power. Again, note that there's an x already there, so I'm going to put that there. The 4 we can express as 2 squared. Now we run into this problem like we did in the past, where we don't want this to be on the bottom, we want it to be on top. So we can go ahead and flip it, make it cross the fraction bar, and in doing so it picks up a negative power. Now we see that the bases are identical. They have to be identical. So since they are, we can set the exponents equal to each other. And solving, we get x is equal to negative 2 over 5 for part E. Part F, we're going to hold off on this part right here. Let's focus on this right side. So if we set this up right, this would be 6 to the 1/3 power, and that's because there's a 1 in the inside and a 3 on the outside. Now it would be, you would think that it'd be convenient to do a factor tree for F, but let's look at this 6 right here on the right side. This 6 is not going to break down to anything but 2 times 3, which doesn't give us any powers. So ideally, if I want to get this problem solved, I need to keep a base of 6. 36 could be expressed, not in the most factored form, but it's 6 times 6, which is 6 squared. So I could do 6 squared, and of course there's an x because it has that x already in the problem. Now doing that, so this is one time when it was convenient not to actually go ahead and do a factor tree. Doing this allows us to have the same base, so I can say 2x is equal to 1/3, and I divide both sides by 2. Oh, interesting. And I get 1/6. You might want to go back and re-watch that one. Maybe even put a left column idea about what we did there. Write down some words. So for part G, notice that all the problems before, there weren't any pluses or minuses per se. It was just one term is equal to another term. But here I have 1, 2, 3 terms. Before I can set bases equal to each other and therefore exponents equal to each other, I have to have just one base on both sides. So I'm going to propose to you, let's add 2 to both sides. And doing so gives me 4x plus 1 is equal to 8. Now I have one base on each side, and I can proceed to take things apart. 4 can be broken down as 2 squared, but I'm using parentheses here so that I make sure we don't make any mistakes. We can check this later if we need to. 8 can be expressed as 2 to the 3rd power. We've seen that a few times already, but just in case, you can do a factor tree. It'll be 2 times 2 times 2, which is 2 to the 3rd power. I can set the exponents equal to each other. And then I should distribute this. Subtract 2 from both sides. Divide by 2.
Anytime you make a mistake, before you get upset with it, look at it.
So you're invited to take this 1/2 and plug it back into here. And then you could put this entire left side of the equation in a calculator. and you'll see that this entire left side is equal to 6. Now this only worked out for us because we went ahead and used parentheses for these exponents, and then we distributed that. If we had not done that, we would have gotten the incorrect answer. Wow, problem H. Okay, the left side is already 2 negative 3x, so that's cool. This 2 radical 2, so what's radical 2? There's a little 2 on the outside and a 1 on the inside. That's a 1/2 power. Now, this is, let's do some more math here. This, we've taken care of this 2, the square root of 2. That's 2 to the 1/2 right here. This 2 was on the outside, and it's to the 1 power. But I could make this, well, okay, let's do this. So, if they have the same base, I have 2 bases and 2 exponents, I add these exponents. So what I'm proposing to you is the following, that this is 1 plus 1/2. That's because I have 2 bases. Remember, we still have to have 1 base on each side. And so they have the same base on this side. They have multiple bases, so the exponents are going to be added up because they're multiplying. Now, this might hurt some of you. But let's do we need a common denominator, right? So we have 1 over 1 plus 1 over 2. I need to multiply this by 2. That's 2 over 2 plus 1 over 2 is 3 over 2. So this whole thing is 3 over 2. Well, great. We have same bases. That means I can make the exponents equal to each other. I'm going to divide both sides by negative 3. I get x equals 3 over negative 6. Which, I guess if you wanted to cancel these out, it would just be negative 1 over 2. Or if you reduce, right? You could take this and reduce, divide them both by 3, you get 1 over 2. Brace yourselves. This one. Okay. 9. 9 is 3 squared. Great. So because the bases are equal to each other, the bases are not equal to each other. The bases are not equal to each other. The bases are not equal to each other. Everything we've done up to this point, the bases were equal to each other. So, check it. If the bases can be equal to each other, then the exponents are equal to each other, and then it's pre-algebra, algebra 1. If the bases are not equal to each other, we can't do anything about it right now. But what I can tell you is that there's something called a logarithm. And this is where the algebra 2 kicks in to full gear. So I am proposing to you that everything we've done up to this point in this video is algebra 2, but it's not beefy. Okay, this part I, we're not able to get the same bases, and so we can't set the exponents equal to each other. So this kind of problem requires us to use something called a logarithm, which will be here forthcoming. So just be aware of that. Summary, for problem 2, parts C and E, what was done to get rid of the fractions? And you might need to review former videos for that. So here's C, here's E. What was done to get rid of those fractions?